Hello everyone, welcome to this tutorial about compositing Redshift AOVs in Blackmagic Fusion. In this tutorial I'll be covering how to set up the AOVs we need to match the beauty. I'm gonna explain the difference between the normal and raw AOVs and how to create one from another with simple math. And we're gonna create some cool post effects like depth of field, motion blur, volumes and relighting. So buckle up, cause this is gonna be a lot of information. Alright, I've set up this simple scene, so let's see what we got here. We've got this cylinder with an animation on it to generate some motion vectors. We've got this refractive cube with a spotlight on it which emits caustics. This cone in the back has an emissive material on it, so it will act somewhat like a light. We've got this beautiful reflective donut and a sphere with some displacement on it, which will become visible in the render. And there's a spotlight on top which emits some nice volume light. And we've got these stacked cubes with some subsurface scattering on it. I've also added the dome light with a free HDR texture to create a little more detail in the specular. And the render settings are nothing special actually. I've set up a 1080p resolution, added some samples, lowered the error threshold. I've added the volume scattering node so the volume light will be visible. I've set up brute force for the primary GI. And I've got enable caustics turned on. Alright, let's take a look at what AOVs we're going to use. We'll start off with the ones we need to match the beauty. That'll be the caustics, caustics raw, diffuse filter, diffuse lighting raw, emission, global illumination raw, reflections filter, reflections raw, refractions filter, refractions raw, specular lighting, subsurface scattering raw, and the volume lighting. These AOVs will work fine with the default settings, so don't worry about that. Next up are the additional AOVs to create some cool effects. First off is the custom AOV. This applies a custom shader to everything in your scene, which will only be visible in this AOV. And in this example, we'll use the Ambient Occlusion shader, which we will add to the composition later. Next up is the Z or depth AOV. What's important when using this is that you set the filter to minimum depth, because we don't want anti-aliasing and we want even the smallest values to be included. Or else you'll get those ugly artifacts in your depth of field, for example. We'll set the depth mode to Z normalize because I like to keep the values between 0 and 1. You don't have to do that, but since I use plugins like Sapphire and Lenskare for my depth of field, they just seem to work better with a normalized depth. Now for the minimum and the maximum depth, the minimum depth should always be 0 in my opinion. Maybe in some animation an object will come very close to the camera, so you'll never have to worry about not picking it up in the depth correctly. For the maximum depth, I just like to turn on object details in the heads-up display and then select the object that's the furthest away from the camera, which will be this cone. Then I can see here it's somewhat 184 units away from the camera, so I'll round it up to 200 just to be sure, and I'll put that in the maximum depth. And then the motion vectors. I like to just output the raw ones simply because it gives the best results. It'll increase the size of your file a little, but that shouldn't be a problem. Remember to turn off the filtering because we don't want anti-aliasing in our vectors. Next up is the normals AOV. We don't have to edit any settings here, it'll be fine. The puzzle mat, we're going to use this AOV to create per object masks. In this example I'll use the object ID, but you can also create masks per material if you like. I'll set red to 1, green to 2, blue to 3, and I'm going to turn on refract IDs, so the mat will be visible in reflections and refractions as well. We're not done yet, we need to define which objects will be in this AOV, so for that we're going to add a Redshift object ID node. Let's pick this sphere, add an object ID node and set the perimeter to 1. So the sphere will be red as we define in the AOV. Then we'll select the cylinder, add another object ID node and set it to 2, so it'll be green. Let's pick this cube in the middle, add another object ID node and set it to 3, so it'll be blue. Finally, my personal favorite, the world position pass. This AOV contains the world space coordinates for every pixel, and you can do some pretty cool stuff with it, which I'll show you later in this tutorial. I'd like to set this to center sample because it seems to give me the best results, but it also depends a little on what you want to do with it. Just remember to set the scale Z to -1, so the Z axis will be inverted. I don't know why actually, but we need to do this in order to match the 3D space coordinates in Fusion. Cool, everything we need is set up correctly, so let's fire up a render. Alright, it's done, and we've got all these AOVs in the images folder, or where you set up the path to render to. And now we can just easily grab and drop them into Fusion. Fusion automatically creates a loader node per file and merges them together. But this is not the way we're going to build the composite, so let's delete all of these. I'm quickly going to rename them so it'll be a lot more easier to see what we're dealing with. Oh, by the way, select a node and press F2 to rename it. Alright, I've renamed them and I've put them in a certain order so I can walk through them easily. First, we'll need to match our beauty render. For reference, I've put it in the left view. In the right view, we'll put our composite. Remember to set the LUT to sRGB, and if you don't have the sRGB views, you can also use the normal Fusion LUT and set the color gamma to 2.2. We'll start with the diffuse filter. This AOV contains the raw diffuse color of your scene. Now, we're gonna add the diffuse lighting to it, but before we do that, we'll have to understand what the difference is between the normal diffuse lighting and the raw one. Well, actually that's pretty simple. Since the normal one has the diffuse filter multiplied to it, we can recreate this using a channel booleans node. By the way, if you want this cool select tool window, just press Ctrl plus spacebar and type in the node you want to be created. Now that we've got this channel booleans node, we'll set the operation to multiply and set the alpha to do nothing, because we only want to multiply the color values. Pipe the diffuse filter in the background, the diffuse raw lighting in the foreground, and we can see it's the same as the diffuse lighting. The same goes for the GI and the raw GI. We can copy the multiply node, pipe in the filter, pipe in the raw GI, and you'll see it's the same as the normal GI. Now that we know how these work, we can simply add them together with another channel booleans node, set the operation to add, and remember to ignore the alpha. Next up is the reflection. Now we've got three types of reflection AOVs here. Reflections, reflections filter, reflections raw. The reflection is just the reflection as you know it. The reflection filter is basically the reflection color value as you have set it up in your shader. The reflections raw AOV doesn't have this color value information from the filter yet, so every reflection color value is set to white. So in order to let the reflection filter function as a mask for our reflections raw and create the original reflection, we can simply multiply them. Just duplicate a multiply node and pipe them in for the result. We're going to add the result to the rest of our composition so far with another channel booleans node. Let's just copy this one. The exact same thing goes for the refraction, so I'm not going to go through all that. I'll just multiply them and add them to the rest. Next up is the specular AOV. One thing to notice is that the environment reflection is in here. That's because it's coming from a dome light, which is a light, and specular is the reflection of light. Now we're going to add the emission AOV as well. Keep in mind that the light coming from an emission is only visible in the GI AOV and not in the diffuse lighting, as you would expect from other lights. Now for the caustics, we also have a raw caustics AOV. That's because the normal caustics have the diffuse filter multiplied to it, and we can recreate that in the usual way by multiplying the raw caustics with the diffuse filter. Same goes for the subsurface scattering and the raw subsurface scattering. We'll add those to our composite as well. And finally, the last AOV we need to match our original render, or as we like to call it, our beauty, the volume lighting. Just add it to the rest and voila, we've got our original render. Now we're gonna have some fun with some post effects. First off, the custom AOV with the ambient occlusion shader. The most common way to add the ambient occlusion to your composite is by using a multiply operation, but watch what happens. Our volume lighting is gone, or at least half of it. That's because the ambient occlusion doesn't have an alpha channel, so it reads the background as pure black, which is 0, and anything multiplied with 0 is 0. So how are we going to fix this? When we look at our original render, we see that it does have an alpha channel, so we're going to copy it into our composition. So now we have an alpha channel, but we still don't see our nice volume rays. Well, we can simply change the order of the composition. So the volume light will be added after the pre-multiplication of the ambient occlusion. Now, to be honest, I'm not a big fan of adding this much ambient occlusion to my composite, so I can lower the blending effect by selecting the multiply channel booleans and lower this blend slider. However, that's pretty much all the control you have when using a multiply channel boolean. The way I prefer is by using the ambient occlusion as a mask for a color corrector. So let's see how to do this. First, we create a color corrector and add it to our composite. Then we pipe the AO in the mask input, set the mask channel to luminance, invert the mask because we only want to affect the darker parts of the AO. And now all we need to do to match the previous method is put the RGB gain to 0. You can also use the AO to create some cool kind of GI effect, maybe add some color, but as we do, we run into our next problem. The alpha channel gets adjusted as well, and you might not want that. That's why we need to check pre-divide post-multiply. So before the correction takes place, the alpha channel will be removed from the composite by dividing it, and returned after by multiplying it back. So now the position AOV. This AOV tells us the per pixel coordinates in RGB values, but in this state it's useless to Fusion, unless we tell Fusion to map these RGB values to XYZ values. The way to do this is, of course, with another channel booleans node. We pipe our composition into the background, the positions in the foreground, and then under auxiliary channels, don't forget to enable them, all the way at the bottom we set the X position to red, the Y position to green and the Z position to blue. Now we can see the position channels have been added with the correct information in them. The same goes for the normals, but now we'll pipe the RGB in the normals XYZ. And we can check if the normals channels have been added correctly. Cool, so now we're gonna do some cool stuff with this. Let's say you've added a glow to this cone, just because it's magically enchanted or whatsoever reason. You also want this sphere to reflect that glow in a nice way. Well, this is where the normals come in. We add a shader node. Put the ambient up to 1 so the original color won't get darker. And now we can use the equator angle and the polar height to adjust the position where the light is coming from. Something like that. However, now everything is being lighted by the shader node and we only want the sphere to be affected. So for that we're going to use the matte AOV. As we can see, the sphere is red, so we pipe the matte into the shaders node mask and set the mask to red. Now the lighting will only affect the sphere. Beautiful. Now, let's say you've sent this render to your client and he replies like, yo, you made this beautiful golden donut, but I want the right half to be silver instead of gold. Now you can do this by rotoscoping the whole part, but it's really time consuming and you'll have to do it pixel perfect. So a better way would be creating a mask that obeys depth as well. And this is where the positions channel comes in. We add a node called volume mask and add it to our composition. And now you can use these translation, rotation and scaling parameters to define an XYZ mask. When you're done, go to the Color tab and check Mask Only. Now you can use this output as a mask for a color corrector. Now we can create actual volumes with the position data as well. So for that we're going to create a volume fog node. Now before we use this to create some cool 3D fog, we need the camera information as well, or else Fusion wouldn't be able to tell the perspective. You can export the camera from Maya as an FBX, but since the camera is standing still, we can simply create one with the same parameters in Fusion. We add a camera 3D node, set the parameters to position Y 20, position Z 60 and rotation X to -6. And then we pipe it into the scene input of our volume fog, and there we have it, a beautiful volume. Now let's adjust the volume so we have some nice fog on the floor. Pretty cool. You can do some light scattering as well. Let's say we want the fog to light up around this emissive cone in the back. We can create, for example, an ambient light. And drag the position to our cone. Crank up the intensity a bit, give it some color. It's up to your creativity really. Now we kinda ruined our volume light again, so let's bring it up front so it doesn't get hurt by our new added volume. Next up, the depth AOV. Now the most common thing to use this for is of course the depth of field effect. For that we're gonna add a depth blur, but we first need to tell Fusion that the information in the depth AOV is actual depth. So for that we're gonna create another channel booleans node, pipe the composition in the background and the depth AOV in the foreground. Enable the auxiliary channels and set the Z buffer to alpha foreground. Now we can pipe this into our depth blur. Make sure the blur channel is set to Z, and since we normalized our depth in our Redshift render settings, we need to set the Z scale to 1. Now we can play with the blur size and the focal point to create some nice depth of field. Alright, last but not least, the motion vectors AOV. We can use these vectors to create motion blur, so for that we'll create a vector motion blur node. But before we pipe in the motion vectors, we'll again need to tell Fusion that these are motion vectors and not color values. And to do that, we again need a channel booleans node. Go to the auxiliary channels and set the X vector to red, Y vector to green. Pipe in the composition, pipe in the motion vectors. Now we pipe this into our vector motion blur and bam, beautiful motion blur. Now, all we need is some wicked background. So let's create a background node and add some fancy colors to it. We want the background to blend in nicely, so we'll add it before the depth of field and the motion blur. Well, that's about it, guys. I hope you learned something from this tutorial, and if you leave some comments, I'd be happy to read them and maybe help you with something. If you got stuck or maybe something doesn't make sense to you, I'd be glad to help you. Have fun rendering with Redshift and composite it into some nice cool stuff in Fusion. Alright, bye bye.